Good morning. Good morning.
Good morning, sir.
Yeah. There's one more chapter, last part, the transportation chapter. In unit 2, here you will have a choice of two questions. One question from transportation problem for 20 marks, and you will have a choice of one more question from assignment problem, 10 marks, and travel salesman problem, 10 marks, 20 marks. So here you are going to get 16 marks theory problem and 4 marks theory. Okay, so this what allocation of marks in this unit. Basically, the transportation problem is allocation method. It is applied to practical problems. That's why it is called as a transportation problem. Let us say just I want to. I don't know today. Pen is too sensitive now. I don't know why. Okay, say for example, you have the number of cities, say for example, here, and let us say now. For example, let us say you have what happened this one? I don't know what happened this pen. I don't know why this happens. Okay, let us say, say for example here, this calculate and apply practical problems called transportation problems. So you have a set of origins and you have a set of destinations. Say for example here, you have one problem like this. I don't know why this happened today. Just sorry for interruption. Okay, say for example here, you have number of cities here and you have number of destinations are here. Okay, so we need to allocate based upon the demand and supply. Say for example, you have here, okay, say some factories are there, or cities are there here, and say for example here I'm going to write here. I'm going to write here some warehouses W1, W2, W3 are there, and correspondingly you have some warehouses at various cities. Okay, like we say about that, 3 factories are there here. Now, from cities to destination, okay, say for example, from warehouse to factory or factory to warehouse, you have to transport something, and there is a cost involved here. Say for example, here, if it is in the rupees matter unit, say if you want to write here 10, so 10 rupees is the cost of transporting from warehouse to factory. Say if you want to write here 25, it's the cost of transporting from factory to warehouse. Okay. So, meantime, what you're supposed to do is you have to make sure that whether it's everything available or not. Say, for example, in factory 1, if the availability is only 30, then you can't supply 35 to warehouse 1, warehouse 2, warehouse 3. You have to make sure that it should be optimally allocated. Say, for example, 10 for factory warehouse 1, and say, for example, 5 for warehouse 2, 15, and warehouse 3, 15. So, total you can say that 10 plus 5 plus 15. These are 3 can be optimally allocated to warehouse 1, warehouse 2, warehouse 3. And also not necessarily that you have to allocate all. You may have to allocate maybe 30 for simple warehouse only, and these things don't have to allocate. So you have to make sure that how much you're going to allocate based upon the supply and demand only. So for example, warehouse has got a capacity of, say for example, only 20 units of things can be stored in warehouse. Say, but factory can supply 30, but warehouse can have a capacity of only keeping 20. Then you can't allocate 20, the 30 here. Say that time you have to allocate maximum 20 only. But at the meantime, you have to make sure that all the supply demand also matched. So come back to this here. So basic objective of this chapter is to minimize the cost of shipping. Say from cities to destination. Okay, or you can say some origin. Okay, origin, the M cities, and you have N cities. Okay, so from destinations. So from M to N, you have to minimize the cost of shipping. That's the basic objective of this chapter. And here we come across three different types of solutions. One is feasible solution, means a set of non-negative individual allocations. Okay, say for example here, allocation you did here. Say for example, factory warehouse has got 20 capacity only, whereas factory one can able to produce 30, but here 20 only. Say for example, 10 you have allocated here, and 10 we can allocate here. So 10 plus 10, 20, and don't have to take from anything from factory 3. So because capacity is only 20, factory 1 can allocate 30, you can take 10 and 10, so totally 20. Okay, so feasible solution means a set of non-negative individual allocations. If you do allocation like this, that is called as the feasible solution. Second thing, basic feasible solution means number of allocations should be equal to m plus n minus 1. M means number of rows. Okay, M means number of rows, and N means number of columns. Okay, so let us say here we are going to allocate the allocation number of allocation should be less than m plus n minus 1. So for example, here you have here 3 rows and 3 columns minus 1, so it becomes 5. Means in the entire table of this 3 by 3, that is a 3 by 3 matrix, you have to allocate maximum of only 5 cells only. So it is called a cell. Okay, that is, say for example, for this cell, say from I'm going to write here C11. Okay, C11. Why C11? Because C stands for cost, first row, first column. Second here C12, first row, second column. C13, first row, third column. Similarly, second one here C21. This is C23. Okay, C23. This is, sorry, C31 means the third row, first column. So here 3, 2, that is the third row, second column, C32. So when you're going to allocate anything within these cells, so that should be less than m plus n minus 1. If it satisfies, means you have obtained basic feasible solutions. That is, the number of allocations should be equal to m plus n minus 1. Next, optimal solution means what? That is, it is the solution obtained by minimizing the total transportation cost. Say for example, you're going to allocate here, you have a cost in each cell, and you're going to multiply the number of units transported, you're going to get the total transportation cost. So when you are minimizing the total cost, means you have obtained the optimal solution. So there are the 3 basic solutions in the transportation. One is feasible solution, means set of non-negative individual allocations. Second, basic feasible solution means number of allocations m should less than equal to less than m plus n minus 1. And lastly, one more solution called as optimal solution. It is the minimized total cost transportation cost. Okay, these are the 3 solutions in transportation. Okay, we'll start with one problem so that you'll understand. Okay, so there are some methods are there here. I don't have space here. I'm going to tell you later. So we'll take up one problem. Meantime, also you can take the problem. Okay, I think I'll use scale. Okay, see here, these are the factories F1, F2, F3, and F1, F2, F3, they are factories. And warehouse requirement is from warehouse 1 requires 5, warehouse 2 requires 8, warehouse 3 requires 7, and W4 warehouse 4 requires 14. Only factory capacity. Here factory 1 capacity is 7, and the factory 2 has a capacity of 9, and factory 3 18. Okay, they are the capacity of the factories. Now I'm going to write here in between the transportation cost from factory 1 to warehouse 1 likewise. Okay, I'm going to write the cost here. I'm going to write here, today is 19, 30, 50. The other transportation cost from factory 1 to warehouse 4 likewise. And the factory 2, 70, 70, 30, 40, 60, 40 is 8 only, 70, and 20. Okay, so they are the costs. Okay, cost for transporting from factory 1 to warehouse 1. Okay, you please take down this problem so it will solve the problems. So there are many methods are there here to solve the determination problem. One is that is northwest corner method. Northwest corner method. Method is also called as a stepping stone method. Stepping stone method. And second one is row minimum method. row minima method. Third one, column minima method. Minima method. Fourth one, Vogel's approximation method called as VAM. VAM, V-A-M, is Vogel's approximation method. That is called as VAM. And lastly, optimality test. Optimality test. Okay. Have you taken the problem now? Have you noted the problem? You have to note the problem. Then only you can solve. Okay. You please note down the problem.
Yes, sir. We have noted down the problem.
Yes. Now we'll do one by one method. Let us say I'm going to start with the northwest corner method, first method. So I told you already, okay, these are the factories. F1, F2, F3 are the factories. W1, W2, W4 are the warehouses. And factory capacity also given here. Factory 1 has got a capacity to store 7 units, 9 units, factory 2, F3, 18. And similarly, warehouse requirement also given here. Warehouse 1 requires 5 units, 2 requires 8, and 3 requires 7 and 14. Now, what you do is, first of all, you have to make sure that this factory capacity and warehouse requirement both are same. You have to add. Otherwise, you have to add a row or a column for the remaining value. Now, check out here. That is 18, 9, 27, 27 plus 7, 34. Okay, it is the factory capacity. This requirement 8 plus 5, 13, 13, 20, 34. So both are same. Now it's very important. First important that you have to make sure that this capacity and requirement should be same. For example, let us say here, if you're going to have only 30 now, and 4, what you do is you have to add one more row by keeping the transportation cost as 0, and you have to add one more 4 here. Similarly, for example, W1, W2, W4, they are the 4 warehouses. So total 34. For example, you got only 30 because if you have 10, suppose, that time you have to add one more warehouse, W5, keeping all the transportation cost 0, and you add one more column. So make sure that these values should be equal, matched, first of all. Very important. Both should be same value. Okay, add. So here 34, 34. So no need to add any row, no need to add any columns. Okay. Okay. Now you have to, I told that we'll start with northwest corner method. So north is this one north, and right side is the west. So first of all, you take the first cell here. Okay, northwest cell. Okay. So here, check out what is the factory capacity. 7 is the capacity, whereas requirement is only 5. So I'm going to allocate 5 completely here. Okay, because 5 is the requirement only. Even though factory has capacity of 7, only 5 can be allocated here. Okay, because of that one. So you can't allocate anything here because the warehouse capacity is only 5. Just to go towards right, because northwest, first north, then west. So check out here how much you can allocate here. So capacity of factory already 5 filled. So only 2 can be filled here. Okay, so only 2 can be filled here. Okay, so now factory capacity of 1 filled now because 5 plus 2. Now down here. Okay, down here. So here capacity requirement is 8, but 9 capacity is there. But already 2 for W2 over. Now we can allocate only 6. 6. So 6 plus 2, 8 over. So FW2 also got over now. Now go towards the right now. 6, okay, I filled already for F2, but the 9 is there. Okay, so 7 is the requirement. You can allocate here 3. Okay, 3, 6 plus 3, 9. Next, come down here, You have 7. Already 3 has been filled. Now we can allocate 4. So 4 plus 3, 7. Next, how much remaining? So 14 is there. And here in this cell, if you want to add 14 here, okay, 14 here, then, so this 14 also got over, this also got over. So at the end, you can say at here, 5 plus 2, 7, 6 plus 3, 9, 4 plus 14, 18. Similarly, so where also 14 over, so 4 plus 3, 7, 6 plus 2, 8, and 5. So these are the what called as the allocation. Now you have to find the total transportation cost. Total transportation cost, TP cost. Okay, that is equals to. So 19 is the transportation cost. You can allocate 5 only plus 30 into 2 plus 30 into 6 plus 40 into 3 plus 70 into 4 plus 20 into 14. This is the total transportation cost using the northwest corner method. It's also called as stepping stone method because look like a step actually. That's what you can say. So it's like a step here. The steps here like this. Okay, that's why it's called as the stepping stone method also. Okay, it's easiest way of allocating the allocation method. So nowadays total multiply all this, you are going to get check out total cost rupees 1015. Okay, this is the total transportation cost using the northwest corner method. A simplest method. Okay. Sometimes in the question paper, they are going to ask you to start with the northwest corner method also. So you should know it. Okay, done. Have you finished?
Yes, sir.
Now, first method got over. Okay, we'll go for now second method. Shit. Yeah, sorry, it's very sensitive. I don't know what happened to this pen. When if it move it, it start deleting everything. Okay, so now we start with second method now. Second method, row minimum method. Okay, so row minimum is check out the rows here. Okay, check out which row you got the minimum cost of transportation. Okay, so it's a 19. I think it's 19. Okay, 30, 50, 10. Check out in the row minima. Okay, so for example, first row, you have 10 here. Okay, 10 is the minimum transportation cost. You can allocate maximum possible allocation to here. Says here, 7 is the capacity, but 14 requirement, you can allocate the complete 7 here for this one. Okay, so 7 allocation. Next, similarly, check out now second row here, second row, 40 is the minimum, okay, 40 minimum. So check out how much maximum you can allocate here. So the requirement capacity is 9, requirement 8, you can allocate completely 8 here. And okay, correspondingly, you can just delete that row because the capacity got over already. And next, similarly here also, okay, because 7 got over means you don't have, you can't allocate anything to these cells. Now third row you have 8, already 8 allocation done now because of that 8 of maximum allocated. Now 20 is the next minimum value. So already 7 allocated, now maximum can allocate 7 only here. Okay, 7 plus 1, 14. Now once again go with the second, second time. Okay, so now here let us say this 7 already got capacity got over, so you can't allocate anything to this row. Second row you have here 30 and 40 is there and 60 is there. Now 40 is the minimum value, minimum transportation cost. Now are 8 done now, so you allocate only 1 here, 8 plus 1, 9. Now go to third row here, third row, here 40 is there and here 8 is there, but 8 you can't because already this requirement of warehouse W2 already over by filling 8 to this cell. So now 40 minimum, check out how much you allocate. You allocate maximum 5 only here, okay, because only 5 requirement. Next, how much remaining? So 5 plus 7, it is 12. 12 remaining how much? 6. 6 allocate to this cell here. Okay, so now check out here. So this 7 will 8 plus 1, 9, and here 5 plus 6, 11, 11 plus 1, 18, 7 plus 1, 14, 6 plus 1, 7, 8, and 5. Okay, so all these allocations done now. Now once again you calculate the total transportation cost. Okay, cost that is equals to, so 10 into 7 plus 30 into 8 plus 40 into 1 plus 40 into 5 plus 70 into 6 plus 20 into 7. So you are going to get some, I think, rupees 1110. Okay, after multiple analysis, we will get this value. Okay, the second row minimum method. Similarly, column minimum. Okay, column minimum is same thing. So just you have taken here row. Similarly, you can take column wise. Okay, first column here, let's say 40 minimum value. Check out how much you can allocate here, and likewise, you have to go with column values. Okay, column minimum method. First column, second column, and all. Okay, it's very easy. I will not going to do. Directly I'll go for a WAM method. That is Vogel's approximation method. Okay, the third method. Okay. Now you have to take the 1 second the same problem you take, please. Okay. You take 1 second this problem. So it's very important method, approximation method, because this for only going to ask examination or even in many of exams. Okay. It's 8. It is 17, 30. Okay, you please try to once again the same table you take now. We'll go for this method, that is Vogel's approximation method. Very important for CIE or SW and all. These are the directly you're going to answer only. Simply called as VAM method. And then we'll go for testing the optimality. Whether solution what you gain, what is right or wrong. Okay. So please take this table once again. Take this table, entire table you take, and I'll continue in next class. At 11 o'clock, you please join at 11 o'clock because 11 o'clock we have one guest lecture by Mr. Kishore Kulkarni.
Okay, sir.
Yeah, please join. Okay, at 11 o'clock sharp. We'll have 45 minutes lecture, then we can think of the class. Okay. Yeah, Arsha, please request everyone to join because it's a respect we have to give for some experts there in this field at least. Okay.
Yes, sir.
Yeah. Okay. See you at 11 o'clock sharp.